let's talk about x actually called not exponents, but exponentials. An exponential is an equation that looks like y equals b to the x. That's what an exponential equation looks like. And you remember how we had basic graphs for like parabolas are what? They're like this. Cubics are like this, right?
Yeah.
Well, and absolute values are like this. They're v, right? Well, an exponential graph either looks like, I'll do it in red. It either looks like this.
Oh, where it goes, and then just goes up.
And that's when b is greater than 1. Like for instance, y equals 3 to the x would look like that red graph. That's the rough sketch of it. It always is going to go through, what point is that right there? 0, comma 1. It's always going to go through 0, comma 1, and it's always going to have a horizontal asymptote of y equals 0. And the reason is because, look at it. Let's plug this. Let's plug x and y values in here. When I plug in 0, actually I like to plug it in kind of in the middle. Let's plug in 0 for x. When I put 0 in right there, what's 3 to the 0?
1.
Exactly. What's anything to the 0? Anything to the 0 is 1. So that's why that point's always going to be part of your basic exponential graph. Unless you like add something to the outside of it or something like that, right? If it's just b to the x, you're always going to have the point 0, comma 1. And then if you put in like a negative 1, what's 3 to the negative 1 equal? Do you remember what to do with the negative power?
So it's 1 over 3.
It's 1 over 3. You remember that? 3 to the negative 1 means you flip it. You flip 3 over 1. You flip it, and it's 1 over 3. So 1 over 3. You follow? Mm-hmm. And what's negative 2? If I plunge in negative 2, what's 3 to the negative 2? It's 1 over 3 squared, right? Because remember this,
9.
Exactly, it's 1 over 9. And what's going to happen as I get more and more negative, this value is going to get closer and closer and closer to 0. It's going to be 1 over 27, 1 over 81, etc. So that value is going to get closer, but it's never going to touch 0. That's why this is an asymptote. Y equals 0 is an asymptote. And what's going to happen to the right as I punch in numbers? When I punch in, let's say 1, what's going to happen? What's 3 to the 1? 3 to the 1 is just 3, right? Mm-hmm. When I punch in 2 for x, what's 3 squared? And what's 3 cubed? 27, etc. So what happens to the right of this? It goes up exponentially. Have you heard that phrase ever? It goes up exponentially. That's where that comes from, because it just skyrockets up. So eventually, I can punch in anything I want. I can punch in 100, but it's going to be way, way up. It's going to be super. So I can the domain of this graph. They're going to ask you, what's the domain? The domain is all real numbers. Even though it looks like it goes up super steep, it'll eventually get to all of these numbers on the x. If I do my little scan, which I teach you guys, that's every line that I draw in is going to eventually touch the graph. But what's the range?
Negative infinity, 0, 0, infinity.
What's the range? If I scan, is this going to touch down here? Are these going to touch the graph ever? No, not until I get above 0.
So it'd be 0,
0, comma, infinity is the range. Okay? Now, I'm not done. Because what if b was... First of all, b has got to be... It can't be... b has got to be positive. But what if my equation was y equals b to the x, but b was between 0 and 1? Let's take, for example, 1/2. If b was 1/2, what's that graph going to look like? Oops, this in black. If b was 1/2, what's that graph going to look like? Let's make our t-chart. Here's our xy chart. Let's do the same thing. When I plug in 0, When I plug in 0 right there, what am I going to get? What's 1/2 to the 0?
1.
I'm still going to get this point right here. I'm still going to get that same point right there. But what's the difference? When I plug in positive 1 up here, what's 1/2 to the positive 1? 1/2.
1/2.
What's 1/2 to the positive 2? But what's
1.
1/2 squared?
No, wait, 1/4.
What's 1/2 squared? It's like 1 over 2 squared, which is what?
1/4.
You follow what I'm doing? So what's going to happen to the right? It's going to do what? It's going to approach.
And then the other part.
And what's the
way
opposite
up.
side going to do? What's the -1
It's
on
gonna
that?
go way.
And what's -2 on that? What do I do with this? Remember what I do? What's 1/2 to the -3, for example? What do? I take these and I flip it. Remember what this negative here does? It flips the inside and it becomes 2 to the 3rd, which is 8. So this is actually going to be the exact flip of the one we saw on the previous page in terms of the basic graph. Make sense?
Yeah.
But we still have the same asymptote, the same horizontal asymptote, and we still have that same y-intercept right there. But it's a
You
flip.
always have the same.
It's a
y-intercept.
flip of that. See how it flips?
Because you're always going to have a y equals 0 as
0, comma 1, exactly. You're always going to have that asymptote. But so the difference is you have to look at whether the b is greater than 0. Greater than 1, or between 0 and 1. That's what you're doing. And so when you learn that in class or when you read it in the book, take note of those little details like that, and then and think it through like this. Think it through with the T chart and think about what it's doing, and hopefully that'll make more sense to you.